Hello, gentlemen. Hope that the problems on transformations was helpful and that you guys got a good understanding of it. Hopefully, you guys also checked out that website. I think it's very, very good and it will help you understand the different types of transformations in terms of shifting, in terms of reflections, and about shrinks and stretches. But let's move on. We're going to talk about combinations of functions. Again, hopefully some of this stuff is review for you. But let's talk about the ones that are pretty straightforward first. We have sum, difference, product, and quotient. All right, and basically, if I just want to add two functions together, I simply just add the different parts of the functions. Same thing with difference. Product, we'll multiply them, and quotient, we just simply divide the two different functions. So these are pretty straightforward. That you should look at. There's a couple examples in the book that are really good. Let's do a quick example on a couple of these, and then move on to something a little bit more challenging. If I have a function f of x is x squared plus 6, and g of x is square root of 1 minus x, let's find what f plus g is. And let's find out what f divided by g is of x. And then we want to find the domain, because the domain is going to be important here. Okay, and we're going to keep coming back to domain, so make sure that you have a good understanding of that. But if I simply wanted to add these two functions together, I simply add this term and that term together, and I get this. Real straightforward stuff. I just simply add the two functions. When I start talking about the domain here, I have to note that I have a radical here, okay, and we know that we can't have a negative under this radical, and so we want this 1 minus x term to be greater than 0. Let me get my pen here. All right, so I want, 1 minus x has to be greater than 0. And so what that means is that x, my domain here, is going to be from 1 to negative infinity to 1. If I plug in any number greater than 1, if I plug in 2, this is going to be negative and it's not going to work. Okay? So hopefully that one makes sense. Let's get rid of this. And let's look at the next one here. If I take division here, I'm just going to simply divide the two, and I get that. Now let's simplify this again. We don't like to have radicals, and so if I got to multiply the top and bottom, I got to rationalize here. Square root of 1 minus x over square root of 1 minus x. And if I do that, this is f divided by g. And again, we need to look at the domain. All right, we have two issues here that we have to think about. One is division by 0, which will tell me right off the bat that 1 can't be in the domain, because if I plug 1 in, that's going to be 0. We know we can't have that. Same issue that we had before in the last problem. So the domain is actually going to be similar, but this time we're not going to include 1. All right, so hopefully that makes sense. Products and differences are very, very similar. Same idea. The more interesting problem is when we have the composition of two functions. And we write the composition of two functions as f bubble g. We call this f bubble g of x, which means f of g of x. So the idea is I plug in a value of x into this function g of x, and I plug that result back into f. Okay? And domain gets a little bit tricky here. And let's do a couple examples. Here's the formal definition of the composition of two functions. But let's look at it visually. Let's get a good idea of what it means. And let's go back to our function machine. All right, and let's look at our composite function machine. And basically what it does is if I put something in, I'm going to get out f of g of x. Okay, so that's what it is. But now let's take a little bit closer look at what's going on inside our function machine. If I look at this, I'm taking a value x, and inside the big function machine, there's two smaller function machines. The first x comes in, it goes into the g of x function machine. So it goes through the g of x function machine, and then it spits out an answer. It takes that answer that it spits out and puts it into the f of x function machine. The result is f of g of x. Okay, so think about composite functions as having two function machines inside the big function machine. All right, let's do an example. Here's my two functions. I have f of x is x squared plus 6, g of x is square root of 1 minus x. Same functions that we've been working with. Okay? And let's see what happens here. Let's go through our function machine here. Let's plug in a value. Let's plug in 0. We plug 0 in. 0 goes into the function machine. Okay, it goes into the g of x function machine first. I plug in 0, I get 1. So I take 1, and 1 comes out of the g of x function machine and goes into the f of x function machine. When I plug 1 into the f of x function machine, I get 1 plus 6, I get 7. Okay, so that's the process that just happened here. That just happened. All right, 0 went into g of x spit out 1, 1 went into f of x, and then it got spit out as 7. And all we see is the 1 coming in and the 7 coming out. Let's do another one. Let's plug in -3. -3 comes in here. I get 4. Square root of 4 is 2. So 2 comes out of the g of x function machine. It goes into the f of x function machine. Okay, when I plug 4 into the f of x, when I plug 2 into the f of x, I get 2 squared, which is 4, plus 6 is going to give me 10. Okay, hopefully this is making some sense. Let's plug in 3. Let's do another one. I plug in 3 into the function machine. I plug 3, it goes into the g of x machine, and all of a sudden it blows up. Let's see what happens. I look at this and I plug in 3. Oh, look what happened. I get -2. Radical -2 doesn't work. Okay, so now let's talk about domain. All right, let's see what we're talking about here. Let's do this example a little bit more closely. Here we have those two numbers again. All right, and when we go through and we do our composite, we have to first satisfy. If I'm looking at f bubble g, the first thing I have to do is find an x value that's going to go into this. Okay, and we know that the only things that I can plug into this are going to be 1 or less than 1, less than or equal to 1. All right, if I don't start there, this whole thing is going to blow up. So let's keep going. There's no restrictions here, though. All right, so we're okay. Whatever this produces, as long as I'm in the domain of g of x is going to provide us with something that I can plug in f of x, because the domain here is all real numbers. So if I keep going here, f bubble g of x means that I have f of square root of 1 minus x. This now means wherever I see an x in this equation, I'm plugging in the square root of 1 minus x. If I do that, I'm going to square root of 1 minus x. And then I'm going to add 6 to it, and you guys should see that I get 7 minus x. The challenge now, when you think about domain, if you look right here, you say, oh, the domain of this is all real numbers. And if I just gave you f of x equals 7 minus x and asked you the domain, you would be right. But the problem here is I have a composite function, and I have to satisfy the domain of g first. Okay, so when I'm looking at the domain, I need to take into account this function first. And the domain of this function is -infinity to 1. If I plug in anything else, we're not even going to get to this next step. All right, so make sure you're looking at that. Sometimes this may be all real numbers, so let's look at this flip problem. Let's do g bubble f. And so first we have to satisfy what's going to work in f of x. Well, I can plug in any value to start. Okay, so if I plug in any value of x, I can get a value for f of x. Now, what we have to be careful of is the output, or the range of f of x, now has to be in the domain of g. I know that sounds a little bit confusing, but it goes back to what we were doing before with the function machine. If I do this, if I continue on, this is g of x squared plus 6. Okay, that should be a plus. Sorry, actually, I could make it a plus right here, like that. Okay. If I come in here, that means wherever I see an x, I'm going to plug in an x squared plus 6, just like this. And if I do some simplifying here, I go right there. And now again, okay, what's the domain going to be here? What values can I do? Well, what you should know is that this, we've got a radical. I can only have positive values, but this is never going to be positive. So there's no values that I can plug in for x to make this work. Okay, so my domain here is going to be the empty set. This isn't going to work. I could do f bubble g of x, but I can't do g bubble f of x. All right, so that's important to know. Okay, hopefully that makes sense to you guys. Here's some practice. Read these sections. These examples aren't too bad. They're important because they talk about domain. Domain is going to be key. Here are some problems here. Again, I don't think they're going to take you too long. The concepts are pretty straightforward. Just need to practice them. We're going to use this idea of composition when we start talking about inverses. Summary, we looked at combinations of functions. Addition, subtraction, products, and quotients. Pretty straightforward stuff. Then we looked at the combinations of composite functions, a little bit more challenging, and we have to pay particular attention to the domain. Okay, and so I would challenge you to practice those and rewatch this video if necessary. The idea of composite functions is going to be important, gentlemen. Make sure you understand it, because in the next section, when we start talking about inverses, we're going to use this concept of composite functions. So if you have questions, again, as always, email me. Okay? Hope you guys have a good day.